wing, we can see the shape of the airplane wing traps more air molecules on the bottom than the top, air molecules by, let's say, wind. Because flow rate is constant, that is the volume of molecules passing through an area per unit of time, we know the top molecules will have to move faster than the bottom molecules to, let's say, get these 5 molecules past the finish line at the same time. So because we have figured out that at the top the velocity is higher to compensate, we know that at the bottom the velocity in comparison will be lower. In order to keep these two quantities equal, as the Bernoulli's equation says they are, this means the pressure on the top will be less than the pressure at the bottom. This difference in pressure creates a net force, causing the plane to have a lift upwards. However, while this is a viable way to explain why a plane can fly, there's more going on than just this. If we could look at the path in which air molecules follow, they would look like this. We have seen this model on a Veritasium video that was shown in physics. Only this begs the question, why does the path of the air molecules follow the curvature of the plane? On the bottom, because these air molecules clearly, as they're in motion, will continue being in motion, and we can see that they will want to go to the right, they are obviously deflected by the airplane's wing. I mean, they cannot go through it, so they are obviously deflected. But what's going on at the top? Why aren't they deflected this way? Why do they follow the curvature of the plane? Well, to answer this, we will introduce something called the Coanda effect. If you recall from the video, air was being blown this way, and let's pretend that this is the olive oil. It had to go around the bottle, come back this way, and light up the candle. And it did it not? The air came this way, and instead of being deflected and going out, it actually went around the bottle to its original point and then took out the candle. This is exactly actually what's happening with the airplane wing. What is going on? Why is the air following curvatures of things instead of just being deflected out? What? The olive oil bottle and candle demonstration was mainly used to prove how air molecules do indeed follow the curve of objects, but we will refer back to the airplane wing to further explain why this happens. So here we have a stationary airplane wing with some atmospheric particles around it, atmospheric pressure particles around it, and there's going to be some wind coming on the left side. Now, because there's friction between air molecules, actually as the wind is blowing these air molecules this way, these air molecules are going to actually drag these air molecules with them, therefore increasing the velocity of this area, therefore decreasing the pressure of this area, creating a low pressure area that will in turn cause a low pressure area in comparison to the atmosphere pressure. Therefore, this low pressure area will cause these molecules to follow the curvature of the airplane wing, therefore causing a Coanda effect. We are now going to look at something called the Magnus effect. As a ball is spinning through the air, it is met by the force of that air going against it. At the bottom, we can see, similar to the Coanda effect, that between the friction of the ball and the air is going to be dragged along the curvature of the ball, and therefore creating a higher force on the bottom going upwards. At the top, however, the air is directly going against the spinning of the ball. This direct oppositeness will create both forces to be weakened. This net force of higher force here and lower force here will cause the ball to have a path of motion to be this way, curving. This can be seen on a curved ball if you focus on the trajectory. It can also be seen throwing various cylinders off a ledge. You may have noticed the first cylinder had a standard projectile motion, while the second one, being lighter and therefore being able to feel its effects, nearly hit the window. These curves in motion both serve to demonstrate the Magnus effect. So to recap, we talked about the Magnus effect being caused by air being dragged and air being cancelled out, making a net force, causing a change in motion, or change in trajectory of motion. And we also talked about lift of an airplane wing, introducing the Coanda effect and how drag down will create an opposite reaction of lift up, and how the Bernoulli equation can also serve to explain how the differences in pressure can also cause lift.
Dear Mrs. Wiggins, please get Angelica an A because she is really smart.